Let us continue. We are on page number 9. We have to see some properties of electric field lines. One we have seen, right, it is going away from the positive charge and coming towards the negative charge. I use the language, it starts from a positive charge and ends on a negative charge. You can see the diagram, it starts from a positive charge and ends on a negative charge. Nothing to by heart. Second property, we have to see that it is always observed the electric field lines are continuous pairs and no break. Also, they never intersect each other. That's the two give reasons. So, these two give reasons we have to find the answer. First one, why they are continuous pairs without any break. Our understanding, electric field line, if it is two or more charges, is not going a straight line, it is going to be a pair. Where it is straight line? For a single positive charge or for a single negative charge, it is going to be straight. So, the tangent to the field line gives the direction of the electric field. That was the definition, the tangent. Here also the tangent. So, our answer, why electric field lines are continuous pairs without any break? Answer, the tangent to the line of force at any point gives direction of electric field. Generally, direction of the electric field continuously changes. We have seen in diagram C and D, the direction of the electric field continuously changes. Hence, field lines are continuous curves. If there is a break, there is no electric field. Electric field is not there means electric field is zero. But electric field is zero, not near the charges, only at infinity. So, conclusion, answer. The electric field line is represented by the tangent drawn to the what we call the curve. The direction continuously changes, so it has to be a curve. If it stops means there is a break means electric field is zero, that doesn't happen. So answer 1 is over. Second one answer, that is going to be give reason. What is going to be they do not intersect. That is simple. That was asked 2-3 times for the exam point of view. I make a tick mark. They do not intersect. Assume curve number 1, electric field line 1. Assume another one, curve number 2, electric field 2, electric field line 1 and electric field line 2, 1 and 2. Now they are intersecting at the point P. Theory says they cannot intersect. Why? I draw a tangent to the first line. This is going to be a tangent. So this tangent will represent electric field at that point. I try a tangent to the next one, next curve. This is the tangent to the next curve. That also is going to be in this direction. So at the point of intersection, there will be two tangents possible. That means there will be two directions of electric field at the same point. At the same point, electric field will have only one direction. It is a direction in which a positive test charge will be moving. It cannot move simultaneously in both directions, so it cannot intersect. Repeat. If they intersect, at the point of intersection, there will be two directions of electric field or two values of electric field. It is not possible. Hence, they cannot intersect. That is a second point. Then some one or two properties are there. We can just glance through it. So, only exam point of view, why they are continuous pairs and why they do not intersect. Study the answer. It is clearly given in page number 9 of our notes. Then comes the next point, what is called area vector. Area of a surface we can represent by a vector. Example, this is going to be the duster. This area, maybe this is 5 centimeter. Example, this is 10 centimeter. So area will be 5 into 10, 50 centimeter square. This area can be represented by a vector perpendicular to the surface outwards. Repeat, this is the area. Now I am keeping my pen, writing pen, this one. So I am keeping it perpendicular, pen and the duster are perpendicular, area vector perpendicular to the plane outwards. It cannot be inwards, it cannot be outward. If the length of the arrow gives the area, the length of the arrow is more, area is more, length of the arrow is less, area is less. So can it be perpendicular to the plane inward? No. Example, I am having an area here, just any area. Area we represent by area A or surface S. If it is a small area, we represent by delta A or delta S. A notation. Small means how small? Just generally we say not very large, area of the room, like that, not very large. So area of a surface can be represented by small area by A or delta A, S or delta S. In the textbook, some places they use delta S, some places they use delta A, they may use delta S. So this is going to be the area, just like as I said, maybe 5 into 10, 50 centimeters square. It can be represented by a vector perpendicular to the plane outwards. It cannot be inwards. Can the arrow be inwards? No. It is a, so area vector. What do you mean by area vector? The area of a surface can be represented by a vector perpendicular to the plane outwards. Let us clarify. This is going to be the area. How I represent? By a vector perpendicular to the plane outwards. If area is more, length of the arrow is more. Area is less, length of arrow is less. How we represent this top area? Perpendicular to the top area outwards. How we represent this? Perpendicular to the area outwards. Outwards means not into that. Perpendicular to the area outwards. Example, I want to represent my front surface area, just assume. Then how I represent? By a vector perpendicular to the plane outwards. Area vector. So what do you mean by area vector? We got the concept. Now we want to introduce what is called electric flux. This we can rub it off. This part is over. Electric flux, that is a main concept in physics. How we understand that? I am having an area that I represent by a vector delta S. One point, this is a plate, this is my hand, my palm I am representing. It is having some area, let us say 50 centimeters square. Let us say this is going to be the area vector, that is going to be delta S. What is the angle between area vector and plane of the surface? Repeat, what is the angle between area vector and plane of the surface? 90 degree. Perpendicular means 90. But remember, angle between plane of the surface and area vector is 90 degree all the time. Now, I draw a vector, an electric field. Electric field is there. Electric field is there. Let us say there can be different situation. Angle between the two I represent by theta. It can be any angle, 10, 20, 30, 40, anything. So, this quantity I know E, electric field. Delta S, area vector of a surface, theta, angle between the two. Then this quantity E delta S cos theta we call electric flux. Now we have studied the dot product of a two vectors E and delta S. Then I expand that. In our standard we studied E dot delta S. E is vector, delta S is vector. E dot delta S, its value will be E delta S cos theta. It is not a vector. E is a vector, delta S is a vector, but what about the resultant one? Not a vector. So that is a main concept. We require in 3-4 chapters electric flux. Later magnetism comes, magnetic flux. So electric flux, magnetic flux we come across in daily life. What is electric flux? I remember E delta S cos theta. What is E? Electric field. What is delta S? Area of the surface. What is theta? Angle between the two vectors. Angle between the two vectors. I represent mathematical way E dot delta S. Those are not comfortable with the vector sign, just remember E delta S cos theta. Anything wrong instead of delta phi, I write phi only, nothing wrong. If I use some other notation, nothing wrong, but remember. So, what is electric flux? E delta S cos theta, where E is the electric field, delta S is the area, and theta is the angle between the two vectors. Angle between the two vectors. Then, it is also seen, there is another way of considering it that we will come across later. It is the number of field lines passing perpendicular to the surface. That will be coming later. Now we can understand E delta S cos theta. Now, what is the unit of that? Most of us will be able to get the unit. Most of us will be able to get the unit. Can we suggest what is going to be the unit of electric flux? E is going to be Newton upon Coulomb. Area is going to be meter square. So we say unit is Newton meter square upon Coulomb. I can write Newton, Coulomb raised inverse and meter square. Newton per Coulomb meter square. What is electric flux? What is its unit? Is it a vector or not? It is not a vector. Then last point, when it is 0, when it is maximum, when it is 90 degree. When it is 0, when it is maximum, and when it is going to be minimum. Our understanding, let us assume this is going to be our area vector delta S. This is going to be electric field vector E. Both are parallel to each other. We have no problem. In this case, theta is going to be 0, cos theta is going to be cos 0 is going to be 1. So flux will be E delta S. So is going to be maximum flux. So we can mathematically follow cos 0 is going to be, theta is going to be 0, cos theta is going to be 1. Is electric field and the area vector are parallel, flux is maximum, So when is the flux maximum? Flux is maximum when the two vectors are parallel. Now, when the two vectors are going to be perpendicular, let us say this is going to be my area vector, this is going to be my electric field vector, possible, both are perpendicular. Angle is going to be 90 degree, everybody knows, theta is going to be 90 degree, what will be cos theta, cos 90 is going to be 0, so what will be the flux? 0. So we say, the flux I can say phi or delta phi, those who are confused, yes, any notation it is delta phi, some notation. This is a Greek letter, remember it is a Greek letter. So when the two are going to be perpendicular, it is going to be what we call is going to be 0. Then when it is going to be 180 degree, electric field is in this direction, the area, so let's say the area vector is in the opposite direction anyway, anyone we can consider area vector in the opposite direction, delta S. So anybody can make out theta will be 180, then cos theta will be minus 1, so flux will be minus E delta S. So it is going to be, so flux can be positive, flux can be negative, and flux can be 0. When the two are parallel, which are parallel, the two vectors are parallel, then flux is maximum. When the two vectors are perpendicular, flux is 0. When they are anti-parallel, opposite direction we say anti-parallel, flux is going to be negative in the opposite direction. It is not a vector, The last point, let us see whether we can understand this or not. Now comes the understanding situation. I am having an area vector. This is my area vector, delta S, area vector, I put it, area vector, that is going to be delta S. Now, our area vector is always like that. Electric field is in this direction. So, everybody knows the two vectors are parallel to each other. Theta is 0, cos 0 is 1, flux is maximum. So, what will be the case? Flux is maximum when electric field is perpendicular to the surface.